a force vector of minus 8I minus 10J newtons and a force vector T of 24I plus 18J newtons acts on an object of mass 4 kilograms. Find the acceleration of the object. Given the object is initially at rest at the point with position vector 2I minus 3J meters, find the displacement after t seconds. Find the acceleration and speed of the particle after 3 seconds. So the resultant force will be, we just need to add the two components together, so it'll be the vector F plus the vector T. So writing them this way around, so it's minus 8 minus 10, but you can use I and J if you want to, plus 24, 18. So minus 18 plus 24 is 16, and minus 10 plus 18 gives me 8. And then using F is equal to MA, we're going to have that 16.8 is equal to the mass, which is 4 kilograms, 4 times the vector A, and therefore the vector A will be 1/4 of 16.8, which is going to be 4.2 meters per second squared. We will note that this is independent of t, so the acceleration is a constant. Doesn't matter whatever the time t is, the acceleration will always be the same in this case. So, as the acceleration is a constant, we can then use the displacement vector is equal to ut plus a half at squared, where u and a are vectors. As the acceleration is a constant, and we know that the initial velocity is 0, so we're going to have s is 0t plus a half times a, which is 4.2t squared. So that's going to be 2t squared, half of 4 is 2t squared, and half of 2 is 1t squared. So we get 2t squared over t squared. However, the initial position is 2i plus 3j given in the question. So hence r, the displacement vector, will be 2 plus 2t squared, 3 plus 2t squared meters. Right, so using V is equal to U plus AT, again we can use that because the acceleration is a constant, otherwise we have to differentiate. Then we know that V, the initial velocity is 0 plus A, which is 4.2 t, which gives me that the velocity vector is 4t, 2t meters per second to minus 1. We knew the initial velocity is 0, so we don't need to add anything in. So when t is equal to 3 seconds, the acceleration is just always 4.2. It doesn't matter what t is. So the modulus of the acceleration will be the square root of 4 squared plus 2 squared, which is 2 root 5, square root of 20, which gives me an answer of 4.47 meters per second squared. The velocity, so when t is equal to 3, the velocity vector will become 4 times 3, 2 times 3, which gives me 12.6 meters per second. And therefore the magnitude of that will give me the speed. So it will be the square root of 12 squared plus 6 squared, which gives me 6 root 5, which is 13.4 meters per second. So this has been a video to show you how to find the displacement, velocity and acceleration vectors, and the speed given some forces and a mass. I hope you've understood, and I thank you very much for watching.